It's a pleasure to be given this opportunity to hold a webinar in the asset management series. We will share with you today the process and methods developed and used in the WSP Global project for the Singapore Land and Transport Authority. I am Ulf Larsson, and I'm heading the Transportation Advisory here in Sweden, a group that was started 2 years ago and now has almost 50 advisors. One of them is sitting by my side today, Mr. Lorenzo Gallosti.
Hello, everybody. It's a pleasure to be here. My name is Lorenzo. I'm a management consultant in the WSP Transportation Advisory Group based in Stockholm, Sweden.
Some practical things. We will run through the presentation in about 15 minutes to allow for questions at the end. And we encourage everyone to log your questions in the chat box during the presentation so that we have them ready before the end of the presentation. The presentation itself is available in the handout box in the GoToWebinar platform. So let's start. But before handing over to Lorenzo, who will guide you from condition assessment to investment plan, I would like to briefly introduce our advisory business model that will be used as a theme for Lorenzo's presentation. It has been trademarked as the integrated pyramid organizational model. And what you see here is showing a generic version for basically all industries. At the base of the pyramid is the bread and butter of WSP's offering, the technical advisory, whether it be electrical, mechanical engineering or civil engineering works, the bricks of the asset. The second layer is the life cycle perspective from planning to building and operations of the asset. And with this as a base, we think that we have a better foundation than any ordinary management consultant to advise in strategic matters, often related to some form of business transformation. Here is a breakdown for a typical railway application. And at the base are the building stones for a rail or transit system, where in asset management we have different tools and methods to collect data and assess the condition of the parts. And based on this, we can build degradation models to follow the asset in a life cycle perspective. This is the foundation for strategic advice support for reinvestments in the asset, so that the intended depreciation curve is maintained. Apart from such financial advisory, an asset management program also requires organizational advisory to transform the business of the asset manager from a technical focus to a financial focus. And thus, the asset management is built from bottom up to provide support for a top-down strategy. Okay, before letting Lorenzo explain how this was all applied in flesh and bone in the Singapore project, just a quick background of the project. Singapore Rapid Transit System, shown vaguely in the background here, is famous for its punctuality, cleanliness, and technical sophistication. It is indeed ranked in the top 10 metro systems of the world, carrying more than 3 million passengers every day. Now, in recent times, some older parts have begun to show reliability problems and indeed have experienced severe stops, which is almost a national catastrophe given the importance of the system for the national economy. WSP was there in the early days to advise the client to start an asset management program. And later, the LTA commissioned WSP to perform a condition assessment and build the foundation for effective investment planning. Okay, let's go to the fascinating aspects of this project, and I hand over to my colleague Lorenzo. Please take it away.
Thank you very much, Ulf. So as Ulf introduced, you will see in the top right corner a small pyramid. In the pyramid, we will go bottom up And starting from the first level, we will see how we gather data, did inspections, did defect finding, and then how we did the condition assessment, aggregated the data, doing some maintenance and operation advisory up to the top of the pyramid with financial and strategic advisory. The first types of assets we're looking at is rolling stock. So this was actually a separate project run in parallel by Joseph Wong and his team in WSP Hong Kong and UK. They were looking at all rolling stock, signaling, electrification, electromechanical assets, power supply, escalators, and so on. They were doing basically visual assessment, functional tests on site for roughly 3 months. And the result of this was a full condition assessment for these sorts of assets. If we keep going in the pyramid, the next will be what we call the railway specific assets when it comes to infrastructure. So track and third rail. To gather data about these assets, we use the quite interesting WSP ATV. It's an all-terrain vehicle that you can see in the picture. It takes high resolution 360 degrees pictures. It takes pictures of the third rail, pictures of the track, and it's also able with the LiDAR technology to do a scanning of all assets in order to make measurements and so on. Everything can be integrated fully in IBM Maximo. This is actually a unique thing that the WSP has developed, but I'm not going to go into much details into this because my colleague Peter Tirenius from the WSP Sweden office will actually talk about it in September in a new webinar, which I actually recommend you to listen to. So let's move on and let's see how we will be able to work with infrastructure assets, meaning tunnels and viaducts. As you can see in the picture, this vehicle was able to take all these high resolution pictures. So during the night, the vehicle was running at 30 kilometers an hour in the Singapore network, taking a lot of pictures, and these were stored in our server and sent to basically WSP Sweden and WSP US. The day after, people were waking up in their offices in New York or in Stockholm, looking at the pictures, doing defect scoring, and basically this kept all the physical walks to a minimum. This saved a lot of time, a lot of resources, and made available for the client a huge number of pictures of the overall network. We also looked at viaducts, as you can see in the small pictures, and viaducts bearings. And for this, we also use drones, which is quite interesting. We use drones to take pictures of, what we call the hard to reach areas. So basically bearings in the water or up above buildings and so on. Let's move then to the last types of assets, which are buildings. So we looked at roughly 140 railway stations and 5 depots, among which the world's largest underground depot. And to do that, our assessor actually walked physically in the buildings. They took pictures, as you can see on the green dots. Each dot is actually a picture. And what is interesting here, what is actually quite innovative, is that everything was stored in the same software. So basically, it didn't matter if we took a picture in a building or if a picture was taken by the vehicle that I showed you before, or in a tunnel, on a viaduct. Everything was accessible by the client into the same software seamlessly. So everything was available at all time. All data were available at all time by the client. The next part, we will move up in our pyramid to see basically what's the next step. So once we collected all this huge amount of data, how we went from this to do a condition assessment. The first step is what we call the asset inventory hierarchy. As you probably already know, every client has its own hierarchy, which can consist of many levels. Some clients have 5 levels, 9 levels, 11 levels, whatever. When we came into this project, they had different hierarchies for different assets, and what we did, we actually redesigned all the hierarchies into a 4-level hierarchy for all assets. And this was important for us to make a consistent subdivision of assets across all the types of infrastructure and electromechanical assets in the network. The second part is to come up with the scoring system and also to the so-called minimum service level. To do this, we actually used an already existing scoring system on a 1 to 5 scale, where 1 is a poor condition and 5 is a as new or very good condition. And this system was used by the Federal Transit Administration years before in the US in a very large condition assessment. And the choice was to use a similar, or actually the same, scoring scale in order to be able to compare afterwards. And we used the same scoring scale also in a later project in Copenhagen, and this allowed us to actually be able to benchmark across different assets. The last thing that it was very useful here was a defects guide. So basically for all asset attributes, so for a column or a crosshead or a wall, we identified all different types of defects, and we wrote in a guide what's a 5, what's a 4, a 3, a 2, and a 1, so that people across basically the globe were able to categorize defects at the same time in a very consistent manner. The next step, once we did the condition assessment, was to actually give the client recommendation about operational maintenance. So based on the assessment and based on some proper documentation review, our assessor gave the client recommendations on renewal activities to actually repair the defects, both in technical terms and economic terms. So not only do you know how to fix the defect, but also how much it would cost, as well as identifying possible maintenance gaps. So looking at the maintenance regime, basically identifying how they will be able to optimize it in order to have better assets at lower cost. And of course, we benchmarked and compared these recommendations with the world's best practices. So basically how this will be done in Stockholm, in New York, in Chicago, or in Copenhagen. And this is something that the client appreciated a lot, and I think WSP should use a lot, because it's what makes us very unique globally. So let's go to the last small triangle of our pyramid, the top triangle. And here I'd like to show you how we will be able to go from data gathering to data aggregation to actually provide the client with financial and strategic advisory. So what you can see here on the left is the so-called degradation curve. A degradation curve is actually a curve that shows how an asset degrades over time. So on the x-axis you can see time, and on the y-axis you will see condition in the 1 to 5 scale that I talked to you about before. And what the client asked us is to come up with how the asset should degrade over time. So what's the baseline degradation curve? So what we did, we looked at existing curves. Some curves were produced years before in the US, for example, by the LTA, but also by other different types of authorities. We reviewed them, we ran workshops, we looked at them based on our assessors' experience, and we came up with a full database of degradation curves for all assets. And after that, we compared the actual condition of the assets in the Singapore network to the expected condition. So when you look at the gap analysis pictures, you will see all the blue dots that represent the actual conditions, and the curve that represents what the conditions should be. So basically, this allows us to present to, for example, the directors or the CFO with an overall picture of all the assets with the actual conditions, and with a plan on how to rectify the defects. So basically, the organization looks at this and says, well, either we rectify now and we invest this much and we get back to the wished line, or we can wait a number of years, but then we will risk to lose a number of years in the asset lifespan. So that's a quite valuable and powerful tool for financial planning. The last part is what we call organizational advisory. So in very concrete terms, when we came into this project, the client had no asset management department. There was just one project manager following us, basically with 2 assistants. And when we left after 2 years, the department counted 40 people. And throughout the project, throughout this journey into the Singapore network, we actually gave them some recommendations, almost often informally, on how to build a cross-functional asset management department, what skills are needed, how to efficiently balance maintenance, renewal, and replacement. And when we left the client with a department in place, able to run by themselves. I hope I showed you in some concrete terms how we actually are able to provide the client with technical and strategic advisory at the same time, and how we did it in Singapore. And with this, I just leave the word to Ulf for a small recap.
Thank you, Lorenzo. For me, it's very exciting to hear all of the knowledge that we've gathered in this, and I'm trying to summarize some of the main takeaways from the project and this webinar. While there are some specific competencies that we developed, and we just explained about financial planning and condition scoring and organizational advisory, on an overall level, the Singapore LTA project is one of the world's largest and most comprehensive asset management projects, and as such, an excellent reference to build new business from. It made full utilization of WSP's holistic advisory offer, in this case illustrated by the integrated pyramid organizational model. And it's exciting to show, as you explained, how we actually use big data in this case to as a base for financial decisions in real life and in real operation, which I think is quite exciting. It's also a prime example of fostering international cooperation. As you explained, we have had many continents involved in this project, and it proves that we are truly locally dedicated with international scale. And just a minor reminder on the library that we developed, the guides for the defect types can be reused in many projects out in the world. Okay, we've run over with a couple of minutes, but thank you all for listening. It's been exciting to share our thoughts with you all. And with that, it's time to see if we have any questions.
Yeah, thank you, Ulf and Lorenzo. It's very inspiring, and we can feel the energy. It was a really exciting project. So just a reminder to all our participants, you can download the copy of this presentation from the handout box. We have a few questions for you. The first one, the rail systems have been repeated as S number 6 and S number 7 under technical advisory on slide 3. Is it intended to assign higher weightage to rail systems as compared to other infrastructure?
The model is just the numbers in that is just if you look at the global technical excellence matrix, we have used these numbers to define what contacts there are in different areas. So the numbering is only reflecting a systematic way of organizing the rail assets. I don't know if you have any comments on how you would, from an asset management point of view, grade the various systems.
No, I think Ulf's reply was correct. I think when I tried to show it, basically rolling stock is a railway specific asset, and also the track, but they are so different. One is electromechanical, one is infrastructure. So we decided to divide them into 2 different things because from an inspection point of view, they're very different.
But as you explained, they will still go into the same.
Right, exactly, in the same category of railway specific assets.
Yes.
Very good. Next question.
Yeah.
Was any consideration given to integrating BIM in the assessments?
That's a very, very good question. So basically, what we decided to do was to start from this IBM Maximo software that was adapted by our colleagues here in Stockholm, and not to integrate BIM at this point in time. But what the client is able to do and will do, and we actually recommend them to do, is to build their BIM technology upon what we gave them and what we provided them. And that's of course possible to be done. It was not part of our project, but I think it's a very good idea to do that. Yeah.
Next question. Did you apply different deterioration rates and profiles to different asset groups? Were components considered separately, or were generalized curves created based on the rolled up groups indicated in the graphs?
Yeah,
Did you have, hold on,
yeah.
it's a long, it's actually a three-part question. Did you have to amend the theoretical curves based on the comparison to actual condition, or were the curves generally supported by assessments?
Okay, excellent question. I'll try to answer most of them at least. The important thing about degradation modeling, first of all, is that it's a financial tool. So basically, it helps to plan financial investments. That is why when we actually came up with the curves, we started from a top level and not from a bottom level. So basically, we did not aggregate up small components, but rather we looked at the overall asset and we create a curve that was similar to other curves of this asset. So in that sense, we did not create the curve based on small components and aggregate them together. But this can be done if the curve has the goal to reflect, to be used for example, maintenance planning or more day-to-day operations. Then you can construct a curve which is much more granular based on the components. I don't remember the last question.
I can read it. Did you have to amend the theoretical curves based on the comparison to actual condition?
No, exactly. No, basically the idea was to make these baseline curves and then to just compare the actual condition to the curve, not to create a curve based on the actual condition and to use that. Because what the client wanted, they wanted to have what is the expected curve and to be able to compare with what the condition was. So basically, the curve was not adapted to the actual condition. Although with regression analysis, you are able to get also the actual curves. But the client wanted to renew the asset to get back to the expected curve.
Just one question for me. How many different degradation curves did you have?
I don't recall by heart, but I think roughly 60 curves, something like that, okay. 60, 70 curves.
All right, next question. Also multi-part question. How did the project perform? Was it a success? What lessons can be learned from it if we bid for or win similar contracts in the future?
Very good question. I think the project was a success, definitely. It's a unique project. It showed to basically the whole asset management world that we can do something unique. We are probably the only company in the world being able to put together technical and strategical advisory in such a complex field. It had the challenges, of course. The client is very also detail oriented and was very keen to get as much information as possible. So it was not always easy, but just to give an example, based on this project, based on the expertise we developed, we won another project in Copenhagen just 1 year after that, where we advised the client about asset management, and we will hopefully win a lot more. And with this webinar, we want to share our knowledge in order to win even more projects. So since this was the beginning of it's not the only beginning, but one of the beginning of our asset management expertise, I think it was a huge success.
It's a great reference. I think financially, in the end, it was a plus project, but maybe not so much as we had hoped for. But I think given that we had, I think, a very good client in the sense that they pushed us, we have developed our methods and tools to an extent which is world leading.
Very good. What software was used for aggregating the data and analyzing, i.e. to create the degradation curves?
So for aggregating the data from the for the condition assessment, we use this software that is developed in Sweden. It's our own software, and it's based basically on Maximo. And for this sort of questions, a bit more into the technicalities, I'd really recommend you to listen to Peter Tirenius' webinar, because he is the guy who developed the software, and he is the guy who will let you know each single detail about this.
Okay, so we'll make sure to share the details of the webinar to this group.
Yeah.
Very good. Slide 11. What is your suggestion to undertake gap analysis in terms of level of asset hierarchy? Do you suggest it to be undertaken at asset attribute level or asset category level? Please provide your suggestion, considering the gap analysis is a good information for the clients to undertake asset enhancement.
Very, very, very good question. When we did this exercise, we worked at large assets. So we looked at, the asset class or the asset type. We didn't look at asset attributes. And this is because this tool had to be used by the financial planners of the company. So basically, already doing it at such a high level, it would provide the client with basically 200 baseline curves, but basically 300 curves divided by lines and stations and stuff. So for this, in this respect, I would strongly recommend to keep a high level, because this gives the client the possibility to look at the overall picture. So for financial planning, definitely keep a high level. If you want to use it for more day-to-day maintenance planning or operations, then you have to go to an attribute level, but then it's a sort of a different story, a different tool.
Okay. Last question. Is your model in Excel or is it in a database application?
Are we talking about the degradation curves, I guess?
Person did not specify. Yeah.
That is actually in Excel.
In Excel. All right. Well, that's it. We have no questions anymore, but we reached our almost by 1 minute our time limit. I would like to thank you, Wolf and Lorenzo, for an amazing presentation. I would like to thank our participants for joining us today. I'm going to wrap up the webinar now. Thank you.
Okay, and thank you for giving us this chance to share our thoughts with you all.
Thank you, Karina.
Bye-bye.
Bye-bye.